What time is it? It's science time.
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us. We are talking about measurement. What time is it? It's science time. Welcome back to DIY Science Time. My name's Mr. C, and I'm so glad you're here to be part of our crew today. In fact, we are talking about measurement. Measurement. Things around us that we can use to measure things, or things around us that we actually measure. We can measure things by their length. We can measure things by their mass. We can measure things by their temperature, and we can even measure time. That's right, measurement occurs all around us, and having the right tools allows us to measure things accurately. So what are we going to do today? We're going to build a few different tools so that you can measure things all around your neighborhood. Are you ready? I know I am. Let's check out all the materials we're going to need today.
We're building a hodometer. You'll need a meter stick, 2 large pieces of cardboard, a ruler, scissors, paper, masking tape, a large brad, a push pin, markers, and last but definitely not least, your super-sized science notebook.
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
This is a meter stick, a standard unit of measurement that everyone around the world really understands. A meter stick actually has 100 centimeters in it. That's right, 100 centimeters. Oh, got it backwards. So, I've got these little cubes, and I want to see how many of these cubes fit onto this meter stick. It looks like one of these cubes has a length of 1 centimeter. We should, in theory, have 100 cubes. That means each one of these cubes has a length of 1 centimeter. Now, because it's a cube, it's 3-dimensional. So you can see this cube has equal sides, and that's what makes it a cube. So we can say it has 1 centimeter length, 1 centimeter width, and 1 centimeter in height. That gives this object a volume of 1 cubic centimeter. That's right. So this here is 1 cubic centimeter. Now, interestingly enough, if we were to put water into this cube and fill it with water, so it's just water, it would weigh 1 gram.
What?
And we can take this 1 cube and stack it up, and if we put 1,000 of them together and have a 10 by 10 by 10 centimeter cube, we get something that looks like this. We also know that the water in 1 cubic centimeter has a mass of 1 gram. And if there are 1,000 of these little cubic centimeters in here, that means this shape, if it was filled with water, would have a mass of 1 kilogram because 1 kilogram has 1,000 grams in it. I know that sounds really confusing, but it's actually pretty simple and pretty cool. That's the metric system. It's a way for us to communicate in standard units for everyone to understand. Standard units of measurement like the meter allow us to speak the language of measurement consistently. In fact, The metric system is based on the number 10, sort of like your 10 fingers. This system of measurement uses grams for mass, meters for length, and liters for volume. So why is everything in the metric system based on 10? In the 1700s, the meter was constructed so that it would equal 1/10,000,000th of the distance from the North Pole to the equator along the meridian. Take a look at this meter stick. It has 100 centimeters, and every one of those centimeters has 10 millimeters, which means that every meter has 1,000 millimeters. Or, if we have an object that has a mass of 1 kilogram, we can say that it has 1,000 grams, or 1,000,000 milligrams. The metric system is a simple way for the entire world to communicate while measuring things. Let's give it a try. With all this talk about measurement, it's time to actually measure something, and we need a hodometer to do that. Hodometers allow us to measure distance really easily, and they're pretty fun to take outside and measure things around your neighborhood. So, first things first, grab a whole bunch of leftover cardboard, and just find as big of a piece of cardboard as you can. Then take your ruler. You're going to measure 15.8 centimeters on a thick piece of cardboard or a thick piece of paper. So there's my 0, and there's 15, 15.5, 6, 7, 8. So that distance from the dot to the dot is 15.8 centimeters. Now we're going to use this as a tool to measure the circumference of our circle. And we're going to do this twice so that our circle is the same 2 times. And I'm going to actually take my pen, I'm going to push through it really carefully not to bend the cardboard. And then on the other side, I'm going to put a push pin through. Now this is going to allow me to make a perfect circle. So I'm going to make the other one as well. All right, so there is our second circle. And now that we have 2, we're going to cut them both out. And you might need some help from a parent because my hands are tired, both of them, from grabbing the cardboard and cutting it. But here, if I did it correctly, I'll have 2 circles that are pretty much the same size. It's gonna work for sure, because what I can do now is I'm gonna take my brad and I'm gonna put it through the first one because that's the center of my circle. And I'm actually going to use my pen and just make it a little bit wider. Whoop, try not to bend and break your circle. Perfect, so that's gonna go through the center. And it's gonna spin on there so it can be a little bit bigger. All right, and then we're gonna put a hole through this one. Perfect. And that spins now too. And we're gonna put these together, but before we do, I'm gonna put some masking tape in between them like a sandwich. And this is gonna help allow my 2 wheels to stick together. If you have another set of hands at home, you might need another set of hands. Yay, we got it. So we're gonna sandwich that together. What you're gonna do then is you're going to close this and put it on it just like that. All right, and so what we have now is a wheel that spins as we roll it. Now, it's gonna be really hard to measure something like this without some sort of indicator. I want you to know that this circle that we just made is 1 meter in circumference. 1 meter, 100 centimeters. So how do we keep track of how far we've walked with our hodometer? What we're going to do is we're going to add an indicator mark on it. So you're going to take another piece of cardboard and you're just simply going to tape it to your handle. I'm going to tape it around so we have lots and lots of support. Now, once that's in position, what we're going to do is we're going to put an arrow here and an arrow here so that we know every time it rotates once and we have 1 revolution, we can count it as 1 meter. So I'm going to make an arrow here. And now, we move a little bit of this out of the way. If we start here, we can roll it. Whoops. So it's a little tight. I'm gonna loosen this up, just gonna give this a bow. Oh, you know what it is this is slippery. There's no friction, so it's not really allowing it to roll easily, but if I roll it across my arm, I can measure how long my arm is. But when we take this outside and actually use it, it'll roll across the ground much more easily because there'll be friction on the ground, on the cement, on the sidewalk, and the grass, and it'll roll really nicely. So what do we have to do now? We have to go outside and we have to do some measuring, and you should also. I wonder what we could measure.
The next time someone tells you a horse is 20 hands tall, they're actually saying the horse is 80 inches tall, because 1 hand equals 4 inches. How many hands tall are you?
Have you ever noticed that recipes call for measurements in cups, teaspoons, and tablespoons? This common measuring system is used throughout the United States. You can find these measuring references in recipes all the time.
I have an amazing experiment for all of us to try, and we're going to see if your nose knows what it's actually smelling. Sharks are organisms that live in the ocean, and they have incredible senses of smell. In fact, they can smell things as little as 1 part per million. That means if you have 1 molecule, say of blood, 1 molecule of blood, they can smell that among 1 million molecules of water. That's incredibly small, and we're going to see if your noses can do something similar. And just so you know, that's like saying 1 inch in 16 miles. That's a comparison. Or we can say 1 minute in 2 years. Or 1 penny out of $10,000. That's teeny, 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 teeny. That's right, teeny tiny amounts. So, let's give our sniffers a try and see if we can actually do the same thing like sharks. First thing you're going to do is you're going to label all of the cups 1 through 8 and then organize them on your table. 1, 2, 3, 4, 5, 6, 7, and 8. And what we're going to do now is we're going to add 90 milliliters of water into cups 2 through 8. A third of a cup is equal to 80 milliliters. So we're going to do 1 80 milliliter measurement, and then we're going to add 2 teaspoons, which gives us a total of 90. Perfect. So each of our cups has 90 milliliters, and now what we have to do is we need to add our tomato juice to cup 1. And for this one, I'm just going to put 60 milliliters in it. That's really strong. I wanted to make sure my nose was working. Yes, that is super strong. All right. So this is where it's going to get fun. We are going to actually take 10 milliliters of our tomato juice and put it into cup number 2. 1, 2. So now, in this cup, we have 100 milliliters of liquid, right? Because we added the 10 milliliters of tomato juice to the 90 milliliters of water. So in this cup, we have 1 part tomato juice to 10 parts total. So 1 to 10. So 1 part per 10. All right? And what we're gonna do now is we're gonna actually take 2 scoops of this and add 10 milliliters of this into cup 3. We're gonna stir that up. So now we have 1 part per 100. And I'm gonna take 10 milliliters and bring it over here. And now here, we have 1 part per 1,000, or PPT, part per 1,000. We're gonna take 10 milliliters and put it here. And now, we have 1 part per 10,000. Take that and move it over here. Cup number 6. Now we have 1 part per 100,000. And now we're gonna take this. Stir it up. And in cup 7, we have 1 part per million. So the question is, which cup will I first smell the tomato juice in? So I'm going to actually start on cup 8 because cup 8 is plain water. That's my test cup. It smells like, doesn't smell like anything. So now let's try our part per million. It doesn't smell like anything. I don't smell anything in the part per 100,000. Let's see cup 5. No, I don't smell anything there either. I don't think I smell anything. All right, that I definitely smell tomato juice. So this is cup 3. Yeah, that's 1 part per 100. 1 part per 100. So I can smell that one really easily. Let me test this one more time. I don't think I can smell it in this one. Nope. Will you and your science crew measure up? Can you measure up to what a shark does in the ocean? 1 part per million? I know I can't, but maybe someone at your science crew can. Give it a try, have some fun, and enjoy this spectacular sniffing activity.
Sometimes, in order to understand something's size, we have to reference it to something else. When we reference something really small and say it's microscopic, it means it's so small and tiny, we can't see it easily at all unless we have a tool like a microscope to see things, like blood cells. And when objects are so massive we can't measure them ourselves, we need to reference another very large object to better understand its size. For example, a battleship is approximately 3 football fields long.
Now, you've probably seen a scale before. At a grocery, when you're measuring produce at the checkout line, you put it on the scale, they tell you how much it weighs, and then you pay for the price per pound. Well, this here is a digital scale, but we're not going to use that today. Instead, we're going to build our own balance scale so that you can measure things at your house and have fun comparing the mass of different objects with your science crew. Also, not only are we going to build this, but you're going to be able to measure some of this candy to compare it to one another to see if you're getting a good deal when you decide to trade your candy for other stuff. First thing, you're going to need a coat hanger. This coat hanger here has 2 little hooks. Now, if your coat hanger doesn't have hooks, that's okay. You can tape your cups to the edge. It'll work just the same way. What I also like about the coat hanger is you can take your measuring tool throughout your entire house. Up into your bedroom where you're trading candy. Out to the front door where you might be trading candy with your friends. To the fridge where you're trading candy for fruits and vegetables maybe. Or if you just want to take it in the living room while you're watching TV and trade candy with your family, perfect. So we have our hanger and it's going to hang there. We can see that it's balanced. Here's the fulcrum. This is where it's all swinging from. But most importantly, we need to build something to hold our candy. So what do we use? We're going to use some cups. Now for this, I'm going to use a little push pin and I'm going to push through my cup And I'm gonna wiggle it around to make the hole just a little bit bigger. All right, we're gonna do that on both. Try to place the hole about the same height or same distance from the lip so that the balance point is about the same. I'm gonna wiggle that around. All right, so now what I'm going to do is I have 2 paper clips. I'm gonna take the 2 paper clips, I'm gonna lift one open and pull it out like this so that I have it nice and stretched out. And then I'm going to take that and I'm going to place it through the hole. Perfect. And then I'm gonna lift it up just like this. And I'm gonna hang mine right here onto that hook. And the moment I do that, it tips, it pivots, because this side has more mass on it. All right, now I'm gonna take my other one, do the same thing. I'm gonna open it up. I'm gonna go to my hole here, push it through, perfect. Kind of close it so it doesn't fall off. Take it over here, I'm gonna hang it the same way. And then in theory, this is going to balance itself out when it stops swaying. And it does. So here's the deal. You're sitting at your house, hanging out with your family, your science crew, you're thinking, man, I need a snack. Someone has little chocolate bars, someone has Skittles, someone else brought marshmallows, and you might be saying, hey, I want to trade my candy with you. So how do you do it fairly? Simple. Use a scale. I'm gonna slide this over here so I can be behind it so I can see to make sure it's level. And the first thing we're gonna do is we're gonna take our little chocolate bar and we're gonna put it in. And the moment I put it in, I see that it kicks up. All right, so I wanna trade my chocolate bar for some Skittles. So we're going to see how many Skittles do we need to balance this out. 1, 2, 3, 4, 5. Not quite there yet. 6. Getting close. 7. Let's see. That looks really close. But what I want to do before I do anything else, I want to stop this from swinging. And I think that's balanced. I think that's really, really close. So we can say that one chocolate bar, one mini chocolate bar, equals 7 Skittles. But what if I want to trade a chocolate bar for marshmallows? How many marshmallows will it take? Let's find out. So what's nice about this scale, I can take this off and I can just dump it back out. So we have 1 chocolate bar and we have nothing in this cup again. And we can see our scale is not balanced. I can take a marshmallow. Ooh, that's close. Is that even? That looks really, really even. So 1 chocolate bar equals 1 marshmallow. But the question is, how many marshmallows, or how many Skittles, I should say, equals 1 marshmallow? So I'm gonna take this one out, take this off. This is really cool. And then I'm going to put this on, put it on the back, just like I had it before. So before we said that 1 chocolate bar equaled 7 Skittles, and now we have 1 chocolate bar equals 1 marshmallow. So in theory, we should be able to say that 7 Skittles equals 1 marshmallow. And there's only one way to find out. 3. So we have 1, 2, 3, 4, 5, 6, 7. It worked. It worked. It actually worked. So 7 Skittles equals 1 marshmallow. 7 Skittles equals 1 chocolate bar, or 1 chocolate bar equals 1 marshmallow in mass, right? So if we're trading sugar, this could be a fun way to actually calculate exactly what the trade is worth to make sure we're getting a fair and balanced deal.
Move over for another fun measuring fact. Did you know that a cow's grass was a measurement used by farmers in Ireland before the 19th century to indicate the size of their fields? A cow's grass is equal to the amount of land that could produce enough grass to support a cow.
The metric system seems pretty simple in comparison. Meters, grams, and liters. I included a list of common units used here. Having these standard units of measurement allows us to measure and conduct amazing science experiments consistently, no matter where we're DIYing. Speaking of DIYing, I wonder if you can construct a smaller hodometer that has a smaller circumference. That might be a better tool for measuring short distances in your house or in your room.
Tick, 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 tick. Oh, wait a minute, that's not a clock. That's a hodometer. Hodometers are used to measure distance. Clocks are used to measure time. And when we're learning together, time sure flies by, don't you think? And speaking of measurement, what about our noses? You have to make sure you record all of your information about this experiment to see if your nose is as strong as a shark's, or should I say, as sensitive as a shark's. And also, the scale, make sure you build one of these scales and use it to trade candy and food with your friends and family and your science crew at home. It's so much fun. Oh, and by the way, if you haven't done so yet, go online. Get your science notebook. This is a great place to keep your information. Store it, record it, and you can go back and visit it anytime to make sure you remember what you actually did during these experiments. What an amazing day. I think this episode measures up, don't you? Keep exploring, keep learning, keep having fun, and remember, science is wherever you are. So we're gonna do 180 milliliter. So we're gonna do 180 milliliter. So let's get to actually building a hodometer. Take 5 milliliters in it, and we're gonna. I wonder we use measurement all the time, all around us. Oh, is that recording? Are we recording?